Hi there, Mr. Muhammed is here. In this video we are going to prove that the beta of mn is equal to the beta of nm. So as you know, beta function is depending on integrals, so we need some tricks to prove that, and we're going to do it in a few simple steps. Now we start by writing the formula of beta function, which says beta of mn is equal to integral from 0 to 1 x to the power of m minus 1 and 1 minus x to the power of n minus 1 dx. Now the most important part of the proof is this let. So let x be equal to 1 minus y. Now whenever we let x to be equal to something, we need to find dx. So if x be equal to this, what will happen to dx? So we find the derivative of both sides like this. Dx is equal to the derivative of 1 is 0, the derivative of negative y is negative dy. And we need to check up one more thing, which is the boundaries. So as x approaches 1, when x approaches 1, what will happen to y? Y must approach to 0 to make the equation correct. So as x approaches 1, y approaches 0. And when x is 0, y must be 1 to make the equation correct, because 1 minus 1 is 0. Okay? Now, if you notice that in the integral, when x is 1, y is 0, so a 0 appears here if we rewrite this formula using this let. And when x is 0, y is 1. Now let's rewrite this formula using this let. It will be integral. And instead of 0, we have 1 to 0, which is fine. And instead of x, we have 1 minus y to the power of m minus 1. And from this, if we calculate y in terms of x, you see y is equal to 1 minus x. Y is equal to 1 minus x. If we do it quickly here, x is equal to 1 minus y. So x minus 1 is equal to negative y. So from this, negative x plus 1 is equal to y. We can rewrite this as 1 minus x. So instead of 1 minus x, we can write just y. So from this, y is here to the power of n minus 1. And instead of dx, we must write negative dy and give a brackets because it's not minus, it's negative. Now, as you know, this negative in front of the dy can go outside the integral because we consider it as an integer. And one more thing, when we flip the boundaries of an integral, we just add a negative outside here. So the integral from 0 to 1, if we rewrite the same integral from 1 to 0, like if we change the boundaries, we add a negative outside. That's what we do here. So 0 is on the top here, so we write 0 here, bottom, and 1. So 1 to 0 is equal to negative 0 to 1. Then we copy these 1 minus y to the power of m minus 1. And since between these terms is multiplication, it's okay if we replace them. It's okay if we rearrange them this way. We can write the brackets second and the other one here, y to the power of n minus 1 first, which makes no difference. And this negatives, look, this negative happened because we changed these, we flipped the boundaries, and this negative with the dy normally goes outside the derivative, so that makes it double negative outside dy. So we just need to refine these negative, that will be just a positive, we don't need to write. Negative will be positive. Now just have a look of this, where we have y n minus 1, 1 minus y m minus 1 dy. and look at the original formula of beta function. Let me zoom out to give you a look of the whole solution here. See? X, m minus 1, 1 minus x, n minus 1. M is here the first, m is the first. N is the second, n is the second here. Now look at this. N is the first, so that makes it to be equal to beta of n came first, and m minus 1 is, and by the way, it's not about coming first or second. It is about this one is with y, so must go first, and this one is with the 1 minus y, must go second. Now we proved beta of mn is equal to beta of nm. Thank you for watching.